If you've been a developer for a while now, I'm guessing something like this has happened to you. One bright and sunny day, you were happily implementing a new feature in an application you'd been working on for months. You had already put the application into production and had many daily users. You were about to finish up a feature that'd make the product even better. Then you got the email. That email. Someone has reported a bug in production. You desperately want to fix the issue. You want to know what happened. But the detail in the error report looks like something that you would get in a ransom note from an inarticulate villain in a knockoff James Bond movie. With a worried look in your eye, you say to yourself, "What's going on in there?" In that moment, what you really need is data, hard data about what's going on in the application in real time. Application Insights is the tool that you need to get you the data about your production web application. App Insights can report all kinds of information about what's happening in real time, so you can know how your users are using the application and how it's responding. The information that you can get out of App Insights is based on what you need to know, and what you need to know is based on which role you're playing. As developers supporting production web applications, we often play several different roles. For example, we often play the role of mechanic. In the mechanic role, we need to know what the machine is doing. We need to know the load on the CPU. We need to know how much memory is being consumed. It's these informations about the underlying machine that we need to be able to analyze in order to know if there's an issue with our software or the machine that's running on. We also often play the role of crime scene investigator. In this case, you just need to know what happened. Something went wrong, and you have to put together the clues to figure out who did it and how it can be resolved. One of the great things about App Insights is a lot of times we can catch the errors before the users even report them. Because we can see the real-time data and know what the application is doing and where it's doing it, we can start to know when we're seeing crashes before people start telling us about it. It's as if you're a police officer that can solve a crime before it's even reported. We also often play the role of track coach. In this one, we just need to know how fast things are. You want to know how fast the web application is responding. You also want to know where you can push it to be even faster. The great thing with App Insights is not only do you have like this general notion of moving faster, you can get hard data about how fast it's moving, and you can get that data before and after the improvement. And finally, we often play the role of anthropologist. We need to know what our users are doing. We want to know what path they're taking through the application. We want to know what they're having a hard time with. We want to know where they're spending their time. And we just generally want to understand what the software could do to make it work better for them. All right, let's say that we know that we want to get data out of Application Insights. How do we add App Insights telemetry to an existing ASP.NET MVC web application? Well, it turns out that Visual Studio actually has really good tooling for this. What I've got here is just the stock website when I came into Visual Studio and said add new ASP.NET web project, use the web template. So I've got it right here. I haven't made any other changes. What I can do is that I can right click on the project and say configure application insights. That'll bring up a new wizard. I have an option to only run it locally or connect it with Azure. I want to connect it with Azure. I'll say next. It's going to ask me which instance of App Insights I want to connect to. I actually want to create a new one. So I'll click on this. And I'm going to say simple web applications, JavaScript, and friends. I can pick my subscription and my resource group and my location, which in this case, those all look good. So I'll go ahead and create that. and it's going to go out to Azure and provision these resources for me. So now that I've got that, I'm going to go ahead and say next. On this screen, it's going to bring the instrumentation key into my local environment. And so I could save the connection string in the local user secrets file, which is what's defaulted to. If I had some other place I was going to put it, I could do that. The thing that's important about the instrumentation key is this is essentially the unique identifier for my App Insights instance. The NuGet packages that are about to be added to this project know how to find the API endpoints for App Insights in Azure. The instrumentation key is the bit that makes sure that my App Insights data gets routed to my App Insights instance in Azure. So I'll say next. It is going to tell me a little bit about the changes that it's about to make here. And I'll say finish. And it's going to make some changes. It's going to install some NuGet packages. And we can see that this was entirely done. Now, just so you have an idea of what was added, let's go into our Git window. And if we look at the changes, if we look at our app settings JSON, you can see that our instrumentation key was added. Normally you would keep this a secret. I consider all of you guys really good friends, so I'll let you know about it. Either that or I'm going to delete this resource as soon as this is over. But that you should keep that a secret. We also added these service dependencies. There was a change to the startup.cs. Let's look at those. So you can see that we added the service with the new services.add application insights telemetry method, and we pulled in our instrumentation key there. And that was really all that was added in the startup CS. In our CS proj file, if we look at what changes it made, yeah, you can see there's just the integration with the resource. There was this additional NuGet package. And the nice thing about this is that once I've launched this, I don't have to make any other changes, and I will start getting some data right out of the box. Alright, so we've added App Insights to this project. Let's see what kind of data we can get without any further modifications. So I'll go ahead and just debug this web application, just like I would any other debugging session. It's going to fire up the local IIS instance, and we'll be debugging. And if we look at this, you can see that here I've loaded my page, and I now have App Insights data right here in my summary of events. So if I come in here, you can see that I can already in my diagnostic tools window see the information that I'm sending to App Insights, and there have been 8 events so far. I'll come back over here. We'll click around a little bit. Just try and generate some different clicks here. So you can see now we're up to 15 events. And what's interesting is that we can look at this data right in the App Insights portal. Now that we've run that debug session, I want to see what data is available to us in the portal. So I logged into the portal, and you can see there's this resource, Simple Web Application, JavaScript and Friends, that I created right in Visual Studio. But it was provisioned for me here in the portal, which we should point out that having done that, there is the possibility to incur cost. That being said, the price for App Insights is pennies a month. The free tier is really generous, so it's not going to be a big cash expenditure. But you can see, with no additional effort to log events, I've got 14 server requests and an average server response time of 79.66 milliseconds. That's some pretty decent information for as little effort as we've put into this. The last thing I want to show you that we get for free is the App Insights CodeLens integration. If you're not familiar with CodeLens, it's this bit of information that is displayed right above a method declaration. In this case, my onGet method has 0 references. You can see the Git history, when I changed it, and there's this new one, 0 exceptions, and if we hover over that, you can see that it's trying to show us App Insights data. When we added App Insights to this project, one of the things you saw was that it created this connected service. And that connected service is tying my App Insights information right into the Visual Studio CodeLens experience. So let's go ahead and launch this in the debugger. And it will load the page as we would expect. And when we hit this breakpoint here on line 21, I can hover over, and we're not doing anything in this method, so clearly we haven't seen any exceptions. We'll go ahead and run this. And this will work as expected. But if we go to the privacy page, I've added a line of code here on line 22 that just blatantly throws an exception. So if I run this, I'll get the error page here as we'd expect, but let me reload this page so we can hit this breakpoint again. You can now see that I've got one exception. I can click on this, and it's saying that in the last 24 hours we've seen one debug exception at this point. And what's really awesome is if we had this in production, we could click on this and see information about how many times this error had happened in our production site. As it is, I can look at the debug information and get some information about how many times it's happened here in my debug session. So if I run this again, you can see that it just updated. Now it's had 2 exceptions. So far, we've looked at the data that you get for free by having the App Insights NuGet package initialized correctly in your web application. But what we're really interested in is sending custom data. We want to be able to send data to App Insights that is specific to the business domain of our application. So let's look at how we can do that. I have added a new API controller named Demo Controller to the application. And there is a get method that's going to take an ID as a parameter. And I'm just going to add some code here to generate a new instance of the App Insights telemetry client and send some data back based on that ID. So the first thing I'm going to do is I'm going to get an instance of my instrumentation key, which I've got in my configuration, and it is named Application Insights Instrumentation Key. And then I'm going to instantiate a new version of the telemetry client. And it's going to take a new telemetry configuration that needs this instrumentation key. And when I added it, the IntelliSense
went ahead and put the fully scoped name on it, Microsoft.Application Insights.Extensibility. I'm going to get rid of this, and we will just add a using statement for that to clean up our code right here. So you can see we now have an additional or some additional using statements for App Insights and App Insights Extensibility. What I want to do next is I want to switch on the ID that was passed in, and we'll say that in the case of 42, we want to have the client track an event. And we're just going to call it the search for meaning. So what this means is when we run this controller and the ID is 42, we're going to send an event to App Insights that is simply named search for meaning. So tracking events could be any kind of domain-specific event. Maybe it's when the user added something to the order pad, or when some important number crunching was done, or when there was something that changed about the infrastructure. Whatever it is, specific to your application, you can track when and where that happened with this track event API. We can also track exceptions. So let's just say that we want to have, in the case of 43, an exception, and we'll send that to App Insights. We could say client.track exception. We'll say new exception. And this will be one too many. Now, as we saw in the demo earlier, the default App Insights API or behavior will send exceptions to App Insights when the controller throws an exception. So maybe we either want to handle that ourselves, or there's some other kind of exception that we want to send to App Insights, or just different metadata. We can do that with this track exception command. And the last one that we want to look at is sending a metric. So this would be some kind of numeric value. Oftentimes we use this to track how long something is taking. So let's say that we want to put a stopwatch around a certain block of code and report back to App Insights how long that specific block is taking. So let's go ahead and let's create a new random number generator. And we'll just go ahead and take a random value somewhere between 1,000 and 5,000, because what we're going to do is have that we're going to have the thread sleep for that long. And we'll create a stopwatch to track how long it took. Now, obviously, in real code, we wouldn't be just generating a random number to wait. We would actually perform some interesting calculation, and we put our stopwatch around that. And to pick up the stopwatch class, I'm going to need to add system.diagnostics, which it looks like I have actually. Oh, I just need to say new stopwatch, that's the issue. And I'll go ahead and start my stopwatch. and I will say thread.sleep for the value, and then I'll stop my stopwatch. But then what I want to do is I'm going to take my telemetry client, and I'm going to track the metric, which I'm going to call the metric long wait time, and I will send the stopwatch elapsed milliseconds. So what we've done here is we have had some kind of event. You can obviously think, in your head, replace this thread.sleep with a call to a database or some external API, and we're just going to time it with our stopwatch, and then we will send that timer value to App Insights. Now, one thing I wanted to point out is that with all of these, we have the ability to send additional metadata. So let's add a fourth case here for 45, and we're going to create a new variable to hold our metadata. That will simply be a new dictionary of string, and we're just going to send two key value pairs. The first one will be the context, and I'm just going to name it Java script and friends demo, and I will send another key value pair with a key of purpose and a value of a teaching example. And what I could do is I could say client.track event, and I could give it another name. In this case, I'll reuse the search for meaning. And you can see I've got optional parameters here for properties, which this is where I'm going to send my metadata. I could also send metrics if I want to send a third parameter here. But for now, I'm just going to go ahead and send that. So now I should be able to run this application, and I'll set a breakpoint up here. And when we load this controller, we should be able to fire off the various events, metrics, and exceptions using this demo controller. So we'll wait for the page to load, which it loaded the index, which we still have a breakpoint on. But if I come over here to my demo controller, and I'll load 42, we hit this breakpoint, and in this case, we're just going to track an event without anything else. So we sent this client.track event info to App Insights. Again, you can see that it's showing up in the diagnostics tool where I sent a custom event, search for meeting. And so I now have that App Insights information mixed in with all of the rest of the information Visual Studio is creating about my debug session. If I do 43, I'm going to track that exception. And I didn't actually throw an exception, but you can see that App Insights tracked the fact in the diagnostic tools that it was an exception. For 44, we'll come in and we'll step through this, and you can see now we're going to have our stopwatch, and we're going to have our thread.sleep, which simulates some long running activity, and we'll send that information to App Insights. And finally, we'll send the version of this where we're going to send a custom dictionary. And to be clear, I could send a custom dictionary to track metric or track exception. They all work essentially the same. I'm simply only doing with track event. So you can see here we're instantiating that dictionary, and we're going to track an event, and this time the event has this dictionary of metadata on it. Now if I pull up my App Insights information, you can see here's where I sent that exception again. But really what we're interested in is seeing this information in the App Insights portal. Here we are back in the Azure App Insights portal for our sample application, and we can see that we've had some additional requests and our server response time has jumped up, probably because we're now waiting. But what if we want to see the custom information we were just logging to App Insights? Well, the first thing we can do is go down to our metrics. And for our metrics, I can pick our custom metric, and I want to see the long wait time. And so you can see that our average was just over 8,000 there. We could also look at the max, which in this case we've only sent one, so they're the same. But we have some aggregation options right here in the GUI to track how this metric has been performing over time. Now we also want to know about the failures, which is the information we sent in the track exception, which we just named it exception. And so you can see that that's actually happened 5 times. And it's put it right in here with like some 404s and some 500s that we've had. And it's aggregating it with some additional information about where it's happening. Now if we want to see our custom events, we can come down here to the Events tab. And you can see that we have 4 events. And we could filter down by date range or by some additional parameters. We can say view more insights, and so we can see that for both the right and wrong spelling of search for meaning, we've had some events show up here in the event statistics. And we can continue to drill in here, and now you can see for this particular event I can see these custom properties that I sent, where the context is JavaScript and Friends demo and the purpose is a teaching example. Alright, we've been looking at how we could do this in sample applications, but what I want to do now is actually look at how App Insights can be used with a real-world application. So we're going to look at an application that we built, and we're going to look at the live production data so you can get an idea of the kind of information you can get out of App Insights.
Factor is an app that we created to help software companies track their time spent on projects and create invoices based on those projects. So you can see here, as a developer, I can come in and add time entries. I've got one here for conferences, and I'm going to go ahead and edit this. You can see that the client, the project, the phase, and the role are already selected. I'll change the hours to be 8, and in the description I'm going to add JavaScript and friends. I'll go ahead and save that. Now let's go see what we can find out about not only my time entries but the other time entries in our App Insights information. To start to see the data that we've got in App Insights, I've come into the App Insights resource inside of the Azure portal for the web application. Right out of the gate, you can see that we do have some data available to us without any work being done. The very standard data like failed requests, server response time, and server requests. But what we want to do is really get into some more of the detailed information. We want to be able to query the things that we've sent to App Insights. To do that, I'm going to click up here on the Logs item, and that will give me some tutorial information and some documentation options. But I can also just come in to this query editor, and I can start typing a new query, and I want to query the custom events. You can see that I'm actually getting IntelliSense here, so I'm going to say custom events, and I want to filter it down to the events where the name is equal to add time. Now there is a time range filter specified by default here to the last 24 hours. We'll look at how we can modify that in the future, but for right now I just want to run this query, and we can now see all of the add time events that have been posted from Factor in the last 24 hours. You can see that the query language here is a new query language. It's specific to App Insights. It is something called Kusto, and it's got a SQL-ish syntax, and it's really quite easy to learn. It also has a little bit of resemblance to F# with this pipe forward operator here. So really what we're doing is we're saying we want to have the custom events, and we're going to pipe those into a filter that is a where filter, and the where is going to confirm that, or it's going to filter the events where the name is equal to a string value of add time. We also have some additional information we can get down here. We can actually start to see that there's quite a bit of data for each one of these events, and we can see, if we start to expand these out, some additional information about what was going on, what session it was in, even a guess as to where the client was at based on their IP address. Alright, let's go ahead and take a deeper look at some of these queries. Like we did before, we'll start by saying we want the custom events, and instead of using the range filter in the GUI, I want to go ahead and put it in the query. So I'm going to say where timestamp is greater than ago 14 days. So if I run this, I should now see all of the custom events from the last 14 days, which, as you might imagine, takes quite a bit of time. Because of how App Insights stores the data, it is very important that we filter for the timestamp early. The timestamp is one of the main ways that the data is indexed by App Insights, and so to speed up the queries, we always want to have the timestamp filter early in the query. Now, one of the things that we notice here is that if we look at some of these records, we can see that there's some additional metadata. So like in this custom dimensions, we can come in here and we can see a username. Now, if you remember when we were sending data to App Insights, we were putting that custom dictionary of key value pairs into our submission to App Insights. This is where that data comes out. So this custom dimensions object has the information that we put in that dictionary. Now, we probably want to be able to query on some of the stuff in this custom dimensions, and we could filter on it directly, but what would make it our lives a lot easier would be to create projection. So what I want to do is I want to go ahead and say extend, and I'm just going to call this username, and I'm going to set it equal to toString custom dimensions dot username. Now what I can do is I can filter right on that projection that I created. So I can say where username equals epotter at apterainc.com. And in Kusto, when we do the logical operator, we need a double equals. You can see I'm using the single equals here to assign something into username. When I'm doing the check, I'm going to go ahead and use the double equals. So I'll run this. And now we can see that I've filtered the data down to just my data. And so I can come in here and look at these custom dimensions. I can get some of the additional details that I sent with this custom action. I can see the standard information that App Insights collects in terms of the count and the role name, some information about the client. But this data up here, the date and the description and the hours, this is all the information that I very specifically logged in Factor. Let's say we want to go beyond just looking up data and say that we want to start aggregating data. Kusto has some built-in aggregation functions that'll feel very familiar to you if you're used to SQL. So what I want to do is, instead of just having this filter where I'm going to say where username equals epotter at Aptera Inc., I'm going to go ahead and say that I want distinct versions of username. And if I run this, I'll see all of the usernames that are distinct. And maybe what I want to do beyond that is I just want to do the count of them. So then I could just say count, and I'll run this one. And you can see that I got 171 distinct usernames that have used the site in the last 14 days. Now, you might say that in this case I could have got that same information from the GUI up here, but if I wanted to put that information on a dashboard, or if I was trying to count something a little more sophisticated, it might be really useful to be able to put this right here in the query. Now let's say we want to get some further information based on how many custom events have happened over time. What we could do is we could take some of this out, and this time what we're going to do is we're going to say we're going to summarize count of timestamp oops, I've got an extra parentheses there, by name. So I can run this and see over the last 14 days what custom events are showing up and how many of each event type have we seen. I could further refine this by putting an order by in here. So I'll say order by count timestamp, which count timestamp is a variable that was created from the count function where we passed in timestamp. And we're going to go ahead and say that's descending. So I can now run this and see the query run and ordered by the count. Now this is interesting, but maybe I want to see a graphical version of it. So what I could do is I could click on this chart tab, and this will drop me into a graphical representation, and it picks one for me. So in this case I'm saying stacked column, but I have other options as well that I could pick. So maybe what I actually want to see is a pie chart. So I could do that and get another interesting visualization there. Something else I could do in this case is, instead of picking the chart in the GUI, is I could put it right here in the Kusto query. So there is another keyword called render, and if I use the render keyword, you can see I'm now getting IntelliSense that asks me if I want an area chart, a bar chart, a column chart, a pie chart. And so I could pick these like we've seen before, and if I execute this, this will look very similar to what we've already seen. There is another chart here that I'm interested in looking at, and that's the time chart. And if I run this one, we now have a nice line graph that works really well with time series data. All right, let's take a look at another one of the really helpful custom functions. We can see here in this chart, especially if we render it as a bar chart, that add time and update time are two of the most commonly used functions. What if I want to know what time of day those things typically happen? I could pick the timestamp, but that would show me like how many times it happened on any given day. What if I want to know how many times add time is performed at 5 o'clock every day, or between 5 and 6 o'clock on any given day? We can write a query to do that. So let's go ahead and clean some of this out, starting over. And we will say that we want all the custom events where the name equals add time, or the name equals update time. And just for good measure, we will say, or the name equals copy time. So we can run this query as it is, and we'll see the results. Apparently I got over 8,000 records back. So let's go ahead and let's pick out the hour of the day that each one of these events was performed at. So again, I'm going to do a projection, so I'm going to extend hour of day equals hour of day for the timestamp. So let's run this and see what we're getting back. And my projection is actually shown here at the end. So you can see here that, yeah, I've got all these values. Looks like primarily they're like 21, 23. Now it's worth noting that all of the times in App Insights are stored in UTC. To cheat a little bit, I'm going to go ahead and subtract 5. I'm on the East Coast of the United States, so I'm just going to adjust for my time zone. I'll run this again. And so you can see a lot of these events are happening around the end of the workday. So what we could further do is we could go ahead and summarize how many times each one of these hours shows up. So I want to say the count of hour of day by hour of day. Let's run this. So now we've got the count of how many times each one of these events shows up in that hour of the day. I, like we did before, would be more interested to see this ordered. So I'll go ahead and just order that by hour of day. And I want to see this rendered as a bar chart. So we have some kind of interesting results here. We can see that our users are typically adding time, updating time, or copying time either around 7 or 8 in the morning, which would be the start of the workday, or around 4 or 5 or 6 in the afternoon, which would be the end of the workday. So what's interesting is just kind of by looking at this graph, I'm starting to be able to get some interesting ideas about how my users are using the software. All right, now that we've looked at how we can collect information from our application and query that information in App Insights, let's go back and revisit the roles and see how App Insights allows us to fulfill these roles more effectively. We looked at how App Insights can collect information about the machine. We looked at how it can collect memory consumption and response time, and this allows us to know how our application is performing in the cloud hardware that we're executing on. We looked at how we can send custom exception information from our application to App Insights. And we also now know how we can query detailed information about those exceptions in the portal. So when we need to find out why crashes happened, we can find out information about what user was creating the error. Maybe we can put together some information with custom events about what they were doing before the exception. We can get not only the general exception data, but also the metadata that we sent along with the exception. And this allows us to much more quickly reconstruct what happened when the error occurred. Using custom metrics, we can send information about how long specific actions in our application are taking. We could put timing around a specific database query or a specific processing event, and we could know exactly how long that tiny slice of the application is taking. In addition, we could run this information both before and after a performance improvement, and we could not only know that it felt like it was going faster, we could get hard data on the performance improvement. Using the custom events, we can know more information specifically about how our application is being used. This allows us to find the features that are most popular. It can maybe help us find features that are underutilized. It allows us to have the ability to track the usage of specific buttons or events or flows through the application. So we can write queries to help us know exactly what our users are doing. When we've gone through this exercise, we're no longer stuck guessing at what the application is doing. We can move from asking ourselves what's going on in there to actually having data so we can see what's going on in our application.